Exercise 5.2, question number 10. Prove that the greatest integer function defined by fx equal to bracket x means greatest integer function x, where x is between from 0 to 3, means 0 is less than equal to x is less than equal to 3, is not a differentiable at first x equals to 1 and second x equals to 2. So first of all we'll think about x equals to 1. Okay, so fx given is integral value of x, and f dash x we know f dash x equal to what? Limit t tends to x ft minus fx upon t minus x, or f dash a, if I write f dash a is equal to limit x tends to a fx minus f of a upon x minus a, means f dash 1 we want to show that f is not a differentiable at x equals to 1, means f dash 1 will show f dash 1 is equal to limit, in place of x we have kept a all over here, so in place of x a, so here in place of x a, in place of x a, and t tends to x, so ft, here in place of x we have kept a, in place of t we are keeping x, so fx minus fa upon x minus a. Okay, so f dash 1 will be what according to this? Limit x tends to 1, in place of a I am keeping 1, in place of a I am keeping 1, fx minus f of 1 upon x minus 1. Okay, now we want to show that function is not differentiable at 1, means I will show that the limit of this function at x equals to 1 does not exist. If the limit of this function at x equals to 1 does not exist, means function is not differentiable at 1. Okay, so first of all I'll find out right hand limit, then I'll find out left hand limit of this function, and if both are not same then I'll say that limit of this function does not exist and function is not differentiable at x equals to 1. So first right hand limit, limit x tends to 1 plus fx, what is fx? Integral of x minus f of 1, f of 1 will be integral of 1 because fx is integral of x, so f of anything will be integral value of that thing upon x minus 1, so that is equal to limit x tends to 1 plus. Now you think, when x is greater than x tends to 1 plus means x is what? 1.01, near to 1 but greater than 1. So if the value of x is greater than 1, then what is its integral value? What is the greatest integer value of a number lying between 1 to 2? 1. Integral of 1.1 is 1, integral value of 1.2 is 1, integral value of 1.5 is 1, okay, minus integral value of 1 is what? 1 upon x minus 1. So this will be what? 0. Numerator will be what? 0. So limit x tends to 1 plus 0 upon x minus 1. Now 0 upon x minus 1 means 0, and limit of constant is constant, limit of 0 is 0. So right hand limit I got 0. Now left hand limit, limit x tends to 1 minus, okay, fx, what is fx? Integral of x minus f of 1 will be what? Integral of 1 upon what? X minus 1, that is equal to limit x tends to 1 minus. Now x tends to 1 minus means x is less than 1, x is less than 1 means 0.99. What is integral of 0.99? 0 minus integral of 1 is 1 upon what? X minus 1. So that is equal to limit x tends to 1 minus 0 minus 1 is minus 1 upon x minus 1. Now I am applying the limit. When we apply the limit, denominator will become what? 0. You see, in place of x1 I keep 1, so 1 minus 1 will be 0. Anything upon 0 is undefined, so this will be what? Undefined or infinite, I can say undefined. So as RHL is 0 and LHL is undefined, so here both are not same, so therefore what you will say? Limit x tends to 1 fx minus f of 1 upon x minus 1 does not exist. So therefore f dash 1 does not exist, means f dash 1 does not exist means directly I can say function is not differentiable, f is not differentiable at x equals to 1. F dash 1 does not exist means function is not differentiable at x equals to 1. Same way we will see for x equals to 2. Okay, x equals to 2. Okay, same thing only. So here f dash 2 will be what? F dash 2 will be limit x tends to 2 f of x minus f of 2 upon x minus 2. Okay, so first of all I'll find out right hand limit. That is what limit x tends to 2 plus limit x tends to 2 plus fx is what, integral of x fix, minus f of 2 will be what, integral of 2 upon x minus 2. So that is equal to limit x tends to 2 plus, x tends to 2 plus means 2.01 or near to 2, greater than 2 but near to 2. So what is integral value of 2.1 or 2.01? 2. Minus integral of 2 is 2 upon x minus 2. So numerator will be 0, 2 minus 2 0, 0 upon anything will be 0. Limit x tends to 2 plus 0. 2 minus 2 is 0, 0 upon anything is 0. Limit of constant is constant, 0. Okay, so this give it 1. Now you find out LHL, left hand limit, limit x tends to 2 minus. Okay, so fx is what, integral of x, greatest integer value of x we can say, minus integral of 2 upon f of 2 is integral value of 2 upon x minus 2. So that is equal to what, limit x tends to 2 minus. 2 minus means less than 2, 1.99 something. So what is integral value of 1.99? That is 1. Minus integral of 2 is 2 upon x minus 2. So we are getting limit x tends to 2 minus 1 minus 2 is minus 1 upon x minus 2. Now when we apply the limit, in denominator you observe, in place of x when we keep 2, so 2 minus 2 is 0, so minus 1 upon 0, undefined. So this will be what, undefined, 1 infinity. So therefore what you say here, RHL is not equal to LHL, or therefore directly you can say here, because infinite, so you will say limit x tends to 2 fx minus f of 2 upon x minus 2 does not exist. Okay, as limit does not exist means f dash 2 is not defined. F dash 2 is not defined means function is not differentiable at x equals to 2.